Hello everyone. Good evening to all of you. Am I audible?
Yes, sir. Good
Yes,
evening.
sir.
Yes, sir.
Good evening.
So this is the first session for week 4. I think this no. This is first session for week 4, and the YouTube link of this session is now available in the calendar. So in the week 4, in week 4 we'll see. Yeah, so please raise your hand first. Okay, let me know your doubts. I will take one by one your doubts and we'll discuss that. And week 4 content is limit of functions, exponential functions. What are the exponential functions? Irrational limits of sequences. What are those? We'll see. And how to find the limit of function and how to determine that the function is continuous or not. We'll try to find the limit of exponentials at infinity also. Limit of at infinity. These are all in the week 4 we have. Okay, so let me go with one by one who have raised hand. First, I will take those doubts. So Aswin is the first one. Hello, Aswin. What is your doubt?
Sir, graded assignment question number 6, 7. Yes, I'm not understanding.
Graded Simon week 3.
Yes, sir.
Okay. Last question.
6, 6. Question number 6.
Okay. Okay. This use this inform is the following information for the question 6 and 7. Which of the following is an increasing or decreasing, a bounded above, bounded below? So what is your doubt here?
Sir, I'm not finding sir, sequence convergent and divergent. Sir, question number 7. Part second. Question number
Is this
7.
increasing or decreasing first? What
Increasing sequence.
increasing sequence? How you are sure this? How you are sure this sequence is increasing?
Sir, value after L. Firstly, we define find sequence and we
How when we will say a sequence is increasing? Suppose if you have a sequence say okay, then say this sequence is said to be increasing when we'll say if it is a kind of,
E.
if it is this one, then we'll say this is increasing for all, right? So this is happening, right? It is very easy to see that if you say on this side, this is greater than, which is the left side is 2 upon n plus 1, which is n is here. So always n is a positive. So the whole thing is always greater or equal to 0, right? Even though it's strictly greater than. So that's why this is increasing sequence. Now, what about the bounded? If it is okay, it is increasing. And what about the boundedness? Is this bounded above or bounded below?
Sir, if it is increasing, then it should be bounded above, right?
How sure? Like how you can say that if it is increasing the bounded above? You have to check. Without checking, you cannot say the sequence is bounded above.
Sir,
Uh,
sir, in some questions, sir, I have seen, sir, in some questions, both bounded above and bounded below are given, but in some questions, are only bounded above are given, sir.
and that's fine.
That's
That's fine. There is no issue. Like some sequences are even the sequence is -1 to the power n. This is both bounded above, bounded below. Even this sequence, you can see that the sequence is an plus 1 is greater or equal to an plus 2 upon n plus 1, where a1 is given, which is 2. Now this sequence is at increasing, and the first term is even 2. So it is give the surety that this is bounded below, right? This is one surety we have that this is bounded below. Because it is, as we just now checked, that it is increasing, and the first term is 2, then whatever the terms will be, it will surely greater than 2 or greater or equal to 2. So it's give that we have a surety that this sequence is bounded below. But we have to check is that sequence is bounded above or not. So how we'll check that is this sequence is bounded above?
Sir, it is bounded above because, sir, when n tends to infinity, then, sir, an plus 1 becomes approximately equal to an.
Sorry, could you repeat, please?
Sir, it is bounded above because I believe that the when n tends to infinity, then that term 2 upon n plus 1 will tend to 0.
10 to 0. How it could be? Even the first term is greater than 0. So how the sequence will go to 0? It will never be go
No,
to
sir.
0.
No, sir. The sequence will not go to 0. The term 2 by n plus 1 will go to 0.
So it goes to 0 then?
Then, sir, I believe an plus 1 must be greater than equal to an, or it become constant like an plus 1, an plus 2, all have the same value.
But it's tending to 0 when the value of n is going to infinity, right? So
Yeah,
when n goes to infinity, an will also will go to infinity.
Yeah. Anyone else here who can say that in a clear picture that how we can say it is not bounded above or bounded above?
Yes, sir.
Yeah. How it could be?
It is the case because an is greater than equal to. So the term an is always going to be greater than the previous term an minus 1.
Yes.
And since it is greater than equal to, it is never really bounded by any one particular value. It can always be greater.
Can we prove? Anyone is here can prove that is that not bounded above?
Sir, I have just applied MCT over this expression. And sir, what I found is, sir, L is greater than equal to L plus 2 upon n plus 1. Sir, I have just subtracted L from both sides. So what I get is 0 is greater than equal to 2 by n plus 1. So
you cannot apply, right? You cannot apply MCT here, monotonic convergence theorem. How could what is the conditions for convergence? This theorem, what are the conditions when you can apply this MCT?
So just review my approach, sir. Sir, if I apply MCT over this,
that is the first thing. Like you are saying, you are applying the MCT. I am saying you cannot apply here.
For applying MCT,
what
we
are
should
the
know
conditions?
that bounded, it is bounded above or bounded below.
The first thing is it should be increasing or decreasing. Okay, as we have increasing. The second thing is if it is increasing, and then the third is bounded above. The condition itself needed that bounded above. Then you are able to apply it there. Then you are able to, with this MCT, you can say the sequence is convergent. Without even, we are not fulfilling even the second condition. First, we have fulfilled the first condition as increasing, but we bounded above. Okay, above. We needed, at least we have to prove is this not bounded above. So how, anyone is here, how can we sure that is it not bounded above? So we can,
when n tends to infinity, by just substituting the values here, see, while taking the limit when n tends to infinity, the term 2 by n plus 1 will tend to 0 because n is in the denominator. But an will be a infinity, the term at infinity, which is definitely going to be infinity itself because it is an increasing sequence. So as this term, as this limit is, as the sequence is divergent, it will not have an upper bound.
So you even while taking the limit, it is not giving the XOT, no? So how you are taking, because this goes to 0, you are people, but how, what happens, what is happening with these terms when n is
So if I may explain.
Yes, sure.
Then, as Aditya said, if we take the limit of it, then it will become an plus 1 is greater than or equal to an, as the other term will tend to 0. If we assume that it converges,
okay,
then an plus 1 will be equal to an.
Okay.
If we take that, then it will become 0 is greater than or equal to 0. So it does not really give any value.
Sir, that's also I'm saying, sir, 0 is greater than or equal to 0, sir. 0 is not greater than 0, so 0 must be equal to 0, and for that MCT must be applied here.
No, even this sequence. Okay, let's do one thing. Okay, we have a1 is equal to 2. What about the a2? Ever you check with the terms? What about a2? Sorry, this is 2 plus 2 upon 1 plus 1, which is 2 plus 1.
3.
We have 3. What about a3? A3 is?
It will be 2 by 3, no, sir.
Sorry? 2 by, sorry, yes, sorry. This is 2 by 3.
Sir.
So this is, okay, no issues. This is 2 by 3. And, okay. We got this term. And what about the next term is, we have 2 plus 2 by 3. The previous a2 is this one, or not even greater. This is greater or equal to. So even this is the a3 is greater than this number at least, and then 2 upon 3 plus 1.
Sir, we cannot comment about a3 actually.
Sorry?
We cannot comment about a3 because a2 is greater than or equal to 2.67.
Because at least we know that a2 is less, a2 is greater than this number, so a3 will also be, as we have increasing, so this give the certainty that at least a3 is greater than this term, right? This is
I'm saying this because a2 is greater than or equal to that. That means the minimum value is that, but we do not know the like
there is no issue. So where I'm commenting a3, this is greater or equal to sign, not equal to sign. Okay, this is greater or equal to sign. I'm not even given the third term. I'm just saying, okay, third term is greater than this number. That's all, nothing more. Even I'm not exactly getting the third term.
Okay, sir.
So what about a4? A4 is also, what about a4? At least greater than a3. So a3 is this term, at least minimum greater than this number. So this is 2 plus 2 by 3. Okay. And then this is 2 upon this number is actually 4, 1 by 2. So 1 by 2 plus 2 upon 4 plus 1. So what is happening here? Can you say something? What is each time is there?
Sir, each time terms are reducing.
Okay, the terms are reducing. What about this one? This each time we have greater than 2. Each term is actually greater than 2 and some number is added.
Each term is greater than the previous one, sir.
Yeah, and even each term is also greater than the previous term. So can we assume that suppose the sequence is bounded above, okay, bounded. If you assume bounded above, okay, bounded above. So let's say the bound is L. Even let's say bound is L would be good. So let's assume that bound is L. That means an, okay, that what it means that an less than L for all n belongs to, for all natural number, this will happen, right?
Yeah, sir.
Yes,
This will
sir.
happen. Okay. So if it is bounded above and we have already, it is increasing. After assuming, suppose we will reach a contradiction surely. I don't know how we will go, but suppose I am assuming that, okay, this is bounded above, okay, and bound is L. That means we have increasing sequence, okay, and bounded above. So it have limit L. Oh, so it have, oh, so let me take another bound. Let's say alpha, I am saying. So alpha would be good. So alpha, so each term is less than alpha. So it is increasing and bounded above. Then MCT now we can apply. And if we apply MCT, then it says that it have limit. So sequence have limit L. Okay. This sequence AN. So this sequence have limit L. So now let's back to our expression. We have this expression. AN plus 2 upon n plus 1. Okay. Greater or equal to. Now, if we take the limit as the MCT we are applying, so this is going to be the same limit L greater or equal to L plus 2 upon n plus 1. Then what is happening here? L minus L greater or equal to n plus 1. And what about this one? This is going to be 0. This is, so this is what? Oh, so we have, okay, we are not reaching to this is going to be 0, no? This is going to be 0. If we take the limit both side, n goes to infinity. So this goes to L, this goes to L, this goes to L, this goes to 0. So, okay, we are not reaching to a contradiction. Okay, this is going to be L, 0 greater or 0. So this is a true thing.
So instead it is proving that MCT is applied here.
So
Yes, sir.
after assuming, so that's why I'm trying to reach a contradiction. Suppose the sequence is bounded above. After assuming to be bounded above, then we are able to apply MCT. Otherwise, no. If you are
Yes,
not
sir.
assuming, then how it could be? You cannot apply MCT.
Yes, sir. I have assumed.
Okay, but we are not reaching to a contradiction after assuming to be a bounded above. So how we can? Okay, so just a minute. Let me check once. So we have just a minute. Any other information I'm missing? Okay, consider sequence n such that this is we have A1 is 2. So which of the following observation sequence is increasing? Okay, bounded above, bounded below. Okay, so how we can prove that? So this is increasing sequence. We are done. And bounded above, if you assume this is bounded above, then each term is okay. Assume this is bounded above. Okay. Then each term is.
Sir, if we are assuming that we can apply that MCT over here, so it is indirectly trying to say that it is bounded above, because MCT we can apply when if it is increasing, then it and has a limit, then it is of course bounded above.
Sorry, could you repeat, please?
Sir, if we are like you said, we are assuming that we can apply a limit, like apply MCT over here in this question. So now we have the limit also with this, and plus it is an in increasing order. So indirectly it is trying to say that it is bounded above.
Sorry, this is the contradiction. Sorry, could you repeat, please? Sorry, I was thinking about this one. Okay, so we reached the contradiction. So yes. Sorry, what you are saying?
Shouldn't it be bounded above, sir?
It should not be bounded above.
Why?
So that's why I'm actually, so let's assume that. Okay, so as we have assumed that, okay, so I'm saying that, okay, this is the condition. Bounded above means we assume that this is the condition we have. So once we have this one, so this is true for all n, right? This is true for, that's the meaning of bounded above. Okay.
Yeah.
Yes, sir.
That's the meaning of bounded above. So that means an plus 1, okay, also less than that bound, okay. This number
Yes,
is
sir.
also going to be this. So if you think about an plus 1 minus an, what is going to be? Just subtract this first equation, this is second equation. What is happening here? What is going to be? Alpha minus alpha, right? So this is an plus 1 minus an less than or equal to 0, right?
Yes, sir.
But what about we have reached an plus 1 minus an strictly, even not even the, right? Strictly greater than, just a minute, that is for each term we have not even the lesser than, strictly greater than. It is strictly greater than 0. And we are reached that an plus 1 minus an is becoming less than 0. So this is the, after assuming to be bounded above, okay, this sequence is bounded above, and we are reaching that, okay, this is going to be what? Less than 0 after assuming to be bounded above. So this is the contradiction we are getting. Here the strictly word is helpful. Otherwise, if it is this thing is happening, no, so then this could be possible. 0 could be there. So sequence could be even, see, even if it is this thing is happening, so what is happening here? This an minus an, sorry, an plus 1 minus an less than 0, and what is happening here? An plus 1 minus an is greater than 0. So this tells you that even an plus 1 equal to n. That means what we are getting? An plus 1 equal to an. If it is these things you are assuming, then this is true for all n belongs to n. But we don't have this one, because we have a1 is equal to 2, and then a2 is greater than a1. And this could be constant. Okay, sorry. Okay. Even this could be, the sequence could be constant also. Okay. I think I'm missing something. Oh, here is the number. Okay, each time is 2 plus. Okay, so this is no, this is correct. Okay, this is correct. Okay, so we have a1 is equal to 2, and a1 plus n. What we are getting here? an plus 1 minus an greater or equal to 2n plus 1. This will actually strictly greater than 0. So we are getting not even here greater or equal to, strictly greater than, and here we are getting less than or equal to 0. So this is the contradiction. Even we are not going to the expression after assuming to be bounded above. So this is, see, I think all of you are not getting, is that?
Yes, sir, please re-explain it.
Okay, so we have sequence first an plus 1, which is greater than or equal to an 2 upon n plus 1. This is for all n. For all n, that's the, here we have to think that. So this is, here is sequence itself given, that's meaning here is for all n this is true. So we have an plus 1, okay, minus an, okay, greater or equal to 2 upon n plus 1. And this is, we know that is strictly greater than 0, right? This is, we have condition. So that means an minus, this is an plus 1 minus an is actually greater than 0. From here we are getting, because this will never 0. This will be never 0 for all n.
It can be 10 to 0, no?
So what is the difference between 10 to 0 and never 0? Is this equal? These two are equal. What is the meaning?
No, sir, they are not equal.
This means that even n will be never 0. This is around 0. This is the around 0. If here is 0, then your number is coming around this one. Okay? Not exactly 0. Okay. Even this sequence converts to 0. It will never equal to 0. It will ever equal to 0. This sequence.
No, sir, it won't be.
For any n, it will never 0. So that's why these terms we are getting, right? And now second things, we are assuming that the sequence is bounded. Sequence is bounded. So that means here an is less than alpha. That bound is, I am saying, okay, bound for all n. Okay, for all n. This is I am saying. So that means for all n This is true. That means for an plus 1 also it will be true for all n. Now we have what? We have two equations, equation 1 and 2. So what we are getting? I am subtracted from equation 2 to equation 1. So which is we have this one. And we are getting this is less than or equal to 0. And this is true for all n. For all n.
Sir, I have a doubt in this. Wouldn't this apply to every single sequence?
Every single sequence or every single term?
No, I mean every single sequence, like any increasing sequence that is bounded. You can apply this, like say a sequence converges to 7.
Okay.
That a sequence increases and converges to 7. Then an plus 1 minus an would be 7 minus 7, which is 0.
Plus 1
I mean,
minus
since it is increasing, that I was talking at the limit, but
okay,
an plus 1 minus an would be greater than 0. That's the definition of a increasing sequence.
Yes.
But taking the limit, an will always be less than or equal to alpha, and an plus 1 will also be always less than or equal to alpha, which is 7 in this case.
Yes.
So an plus 1 minus an will also be less than or equal to 7 minus 7, which is 0.
So that is limit. No, that is limit. That is limit. You are talking about the limit. Here is on limit. But here we are talking about for all n. That's why the bounded thing is. What is the bounded meaning? For all n, this could happen. Even I am taking the much larger bound. Like if suppose some term is greater than some term, it is happening. I am taking that more larger alpha. That okay. I am assuming that is a large enough that even for this is true for all n. And
Yes,
why
so
this is contradicting? This is why contradicting because of this 2 upon n plus 1. This says that this is strictly greater than 0, strictly for all n. Even this will never be 0. How it could be 0? This will never 0. How you can get? So that's why this is strictly greater than 0, and this says less than or equal to 0. The terms could be either constant or negative once you subtract it. But it says, this says that okay, always positive thing will happen. So that's the here contradiction. And there are different things also we can prove. There are different way also we can prove. So because of this term is enough. Even A1 is not deciding here. Okay, A1 is even not. If A1 is here given 2, here if A1 is given 2, so this is even not deciding this one is that sequence is bounded. For in A1, if you assume any A1, no, it will work that it is not bounded.
So still, like, sure,
Okay.
at a limit, it will be 7 minus 7 is equal to 0. Okay, sir. But it is bounded by 7, no, sir, if it is converging to 7.
Okay, bounded by 7. Okay, that's fine. Okay, so then.
Yes, sir. So since it is increasing, an plus 1 will be always greater than an minus 1.
Yes, okay.
So an plus 1 minus an would be giving a positive number.
Okay.
Positive difference. So we can still apply this, no, sir. Like an plus 1 will be less than or equal to 7 for all n.
Okay, you are saying this one that we have a sequence n which is converging to 7 and which is increasing n plus 1. Okay.
Yes, sir.
And this is happening. This is
Yes,
so converging, increasing, and this is greater or equal to 0.
Yes, sir.
Okay. So this is the thing we have that okay, increasing means this is happening and converging to 7. So that means our sequence is a kind of like here is 7. Okay, let me make it. So here is 7. So our sequence is below of it like this.
So, sir, since it is converging, so shouldn't it be bounded below?
Not sure. We have different sequence also. It is not sorry, bounded below. So yeah, every convergent sequence is bounded, no? So yeah, this is bounded above, so bounded below also. If it is converging to 7, that's the meaning here it is bounded.
So it is not necessary to be bounded above if you're converging to a bounded below no sir. Like take 1 by n for example. It is converging to 0, but 1 by 0 will tend to infinity.
1 by 0 is goes to 1 by 0 is there is no meaning of, right? This is generally says that this notation or even this term is undefined, indefinite, undefined. So that sign is here. What is the meaning of this sign is we are unable to decide the number. That's why this sign is given.
Okay, sir.
Okay, so let's do a different proof. Okay, let's do a different. If it is more confusing, so this is one term is actually deciding that the sequences. So
by taking example, can you prove,
this
sir?
sequence, this is exactly different from this one because of this terms is actually deciding. Okay, let's do a different proof. Okay, I am assuming okay the sequence is less than for alpha for all n. Okay, so that means we have what 2 plus. So we have this an minus 1 is also less than alpha for all n. So which is, or we can write here, this term is an is actually greater than what? 2 plus, sorry, an minus 1, okay, an minus 1 plus 2 upon n plus 1. We have this one. Even we can, what we can think, okay, this is an. So we have to construct something. So let me think that this is an plus what I am constructing 2 upon n plus 1. Okay, this is less than or equal to, I am adding both side alpha plus this one. Okay, this is for all n belongs to the natural number. So what about this one? This is going to be an plus 1. This is what we have. This is, oh, here is, this is an plus 1, which is less than alpha upon 2, sorry, alpha plus n plus 1. Okay, this is we have, okay, just a minute. This we have, so if you take the limit is going to be, limit is bounded above, okay.
Sir, can we take some other problem?
Yeah, sure. So
yeah, we can look at
I
this
think
in the end.
this is enough, but I am thinking to the different proof is there with the term wise. Okay, we should reach a contradiction. I'm actually missing somewhere. Contradiction. Just a minute. Just I will give a 1 or 2 minutes.
In one of the question, can you please try it out? Like in a different question of the same graded assignment, the proof.
Yeah, just a minute. Let me give 1 minute. Okay, let me give 1 minute to prove it. If I'm not able to prove, then I will post the solution. Okay, with the different method, because once we have done this one, this is because of this term. Even this is not depending the even this a1. Because of this 2 upon n plus 1 is actually a surety that this is not bounded above without any harm. But with the different thing that, okay, with the different contradiction, I want to reach that if we assume that, okay, this sequence is bounded, if we are assuming this is bounded, so we can apply, even let's just a minute, okay, if we are applying MCT, Yes, two, please. Okay. This is we have 2 plus 3 plus we have 2 1 plus 5 3 plus 5 4 plus. Okay. So see, actually, see, this is a series, a kind of. So all of you know the partial sum, right? As we have partial sum is taught by sir. Partial sum in this.
Yes, sir.
Partial sum have sir taught in this. So here is what is happening here. So if you will continue this one. So see, this is true, right? This is A1. If you are assuming A1 is equal to 2, okay, and then A2 is what is going to be greater than this number. And what is A3? A3 is what is going to be, this is the minimum number, right? So we can give the number here, and the next number is what is 2 upon n plus 1. So at least A3 is going to be greater than this number. A4 is going to be greater than this number. So what is happening here? Similarly, AN is going to be greater than 2 plus 2 by 3. Okay. Okay. 2 by 3 plus 2 by 4 plus 2 by 5 plus continue is that. This is continuing. So what is happening? So look, we need to consider this one. So this is going to be what? 2. Okay, this is 2. And if you take common here, so this is going to be 1 by 3 plus 1 by 4 plus 1 by 5. It is a kind of continuing, right? So this we can, so the same number, this is going to be, here is 1 by 2 is missing. So I am just adding here 1 by 2 and 1 by 5, 1 by 4 plus 1 by 5. And I am subtracted here. In the last, I have just subtracted. So there is no issue. So this is not, this is going to be equal to sign now. This is not greater than, this is after this sum, this is going to be. This, that means here AN is lesser, AN is greater than. Here is the equal to sign. This is happening after this sum. So here is equal to sign is happening with this expression is equal to the same. So this is 2 sum. This is what? 1 by n minus 1 by 2.
Sir, that 1 by 2 must be inside the bracket.
Sorry, why inside the, oh yeah, it should be inside the bracket. So if it is inside the bracket, then outside going to be 1, right? Yes. Outside going to be 1. Correct?
Outside it will be 1 by 4, no sir?
Yeah.
Oh, just a minute. I am just adding and subtracting 1 by 2. Okay, this is with the this is the number we have. So this is we have. So now I'm just multiplying here again 2, right? So this is going to be -1. So correct. This is going to be -1 will be subtracted outside of this. 2 is going to be -1. So finally we have this one.
So you are taking 2 common, no sir? So if you take 2 common out of half, then it will become a quarter.
No, whatever I am taking here, I am taking common 2. So this will get, here is 1/2 is missing and just added. Okay, let's be continue. I just added here and okay, this is going to be 1/1. Let's take 1/1 we are taking. So this is 1/2, right? I just added and subtracted.
Yes, sir.
Now I'm just multiplying.
Understood,
I'm just opening. This is 1 plus 1/2 plus.
Yes, understood.
1/n, and this is finally 1. So this is a 2 summation 1/n minus 1. And now what we can say about this one? Summation 1/1. Is this series? This is a partial sum, right? This is summation. This is not 1/n. This is going to be I. I is equal to 1 to n. That means here I is equal to 1 to n. This is 1 upon I thing is happening. Correct? This is the series. What about this series? Is this series is this sum is bound? It has some bound?
Yes, sir. It is bounded.
Yes, sir.
What is that number?
Sir, 0.
No, this is series, right? This is actually.
It would be 2, no sir?
Where is 2? Here is, I'm just thinking about this one. What about this sum? Is this sum is bounded?
No, sir. It is not.
Why?
Sir, because the numbers will continuously add inside it.
Can we give a proper proof?
So since it has number n, so nobody's sure about till what extent the number can go. So because of that, it doesn't have bound. It's not bounded.
No, it is bounded means is this series have the sum? Is this sum will exist for all n? Sum will exist for all n?
Yes, sir.
That's the condition how the sum will exist. Just a minute. Where is that?
Sir, sir, is it like a 1/n sequence?
This is 1/1 series. This is exactly 1/1 series.
So in one of the lecture, in 8th lecture, I think professor told and discussed that, and also told that for 1/n series, MCT applies and it has the limit.
No, series. This is not going to be, actually this sum is not exist. Sorry, this is not going, we are not going to a finite sum. This don't have finite sum. Just a minute, let me give the proof also. What is that proof? Okay, so let me give the proof also. That the proof is actually a bit tedious. Actually, if you see I think in the sir lecture in lecture sirs, if you see clearly that this series is not convergent. Means convergent means this sum is not exist. This is exactly 1/n. This is exactly 1/n. This is actually nothing but this is 1/1 series, 1/n, where n goes to infinity. So if you take the, so if this, so that's the, I will let you know. Okay, this is actually not okay. So for the timing, I will prove it. Okay, now itself here, but for the timing, so see that what is happening for the all n. So this is what is happening for n. We reaches to this sum, and if you take now the limit, even this sum is not exist. This sum is not exist, means not convergent. So how could be an bounded? An is actually greater than with the sum. So even this sum you are, so actually what it means that this goes to infinity. This means that, okay, this is -1. So this is -1. So this whole is actually, this is goes to infinity. 2 times infinity again goes to infinity, and -1 is subtracted, nothing, there is no issue. So the whole term is actually going to infinitive as n is increasing. As n is increasing, so that means actually, and what is our term? An is actually greater than for n. So as n is goes to infinity, this is also going to infinity. By this way, we can say that this is not bounded above. But we need to prove that is this series, is this term, this 1 by n, or even whatever I just wrote here, this is convergent or not. Convergent means this series is convergent. The meaning of you getting that, all of you are getting what is the meaning of series is convergent?
Yes, sir.
Series is convergent means sum is exist. But here is I am saying here this sum is not exist, means this series is not convergent. That means not convergent means this is a positive term series. That means it is a divergent. This is a divergent series. That means it will go infinitive. The whole term. So finally, whole term will go to infinitive as n goes to infinitive. And our each term is actually going to be greater than which each n, with the each n here this right side. So that's why this will go to infinity also. So if you see the lecture, this is I think sir have said so that because I know the proof it, but the proof is whatever I can prove easily. So just give a minute. I can prove, or for the timing, if you see this lecture, I think sir have said that this is not convergent. This series is not convergent.
Yes, sir. This series is not convergent, but 1 by n square is convergent. That he said.
1 by n square is convergent. Correct. This series is convergent. This is summation 1 by n square is convergent, but this series is not convergent. This is not convergent. Okay. So we can prove it also. There is a way to prove it. Just a minute actually. So by this way actually what we can actually we want to prove this 1 plus 1 by 2. So quickly let me prove that. So this is the term we have. So what we can do, so think about this one, the two term sum I am taking the same. This is the plus sign, so there is no issue. I'm just putting the bracket here. So what about this one? This term is greater than 1 by 2. This term is greater than 1 by 2 or not? So what is the meaning here? 1 plus 1 by 2 is greater than 1 by 2. Okay. And this 1 by 3 plus 1 by 4 is also, if you check that, this is going to be greater than 1 by 2.
Yes, sir. 7 by 12.
1 by 2. It is going to be greater than 1 by 2. And what is happening here? Actually, the sum is not 2, 2. Now the next term you will take 1 by, so this is 1 by 5 plus 1 by 6 plus 1 by 7 plus 1 by 8. This is the term you will take here in the one bracket. So this whole term is actually again going to be greater than 1 by 2. Similarly, by this, this is a proof. Actually, this is a proving. So this is a bit tedious that this series is going to be convergent. Okay, there are different tools also to prove it. Actually, there is a term in this one, but I think sir have shown that or just said that this series is not convergent. You can use it here. Otherwise, there is a term on the series that if it is n is greater than 1, sorry, r is greater than 1, then series is going to be convergent. This is a rule, or this is a theorem. If it is r is, see that this is n to the power r. If this is greater than 1, then the series is convergent. And if it is 1, r equal to 1, then divergent. So r equal to 1 is the same, our case is happening. So this is divergent. That's why it is divergent. So proof is, I can skip, even if I will start writing the proof, all of you will not get that how the proof is going. Okay. But you can assume that this is the divergent series, and by this way you can tell that the sequence is not boundable. Because that contradiction is not working here for me. I assume that this is going to be using the contradiction. Once we have assumed by this way, actually, so this is correct. Okay, this is correct. There is no issue. This, because of this term, see, the term is what? Because of this term is actually the same term. This term is actually creating a factor with this series also. Because of this term is actually I am contradicting here. But if you are, all of you are not understanding this one, take a time. Okay, this term is actually saying to be no, even for any. Okay, for any one, for if you assume any 1, you can assume any, even you can assume 0. If you assume it is 0, still this sequence is not going to be convergent because of this term only. And the same term is creating a factor in the whatever I am now proving it with the series thing. The same term because of the only this term. Okay.
Sir. Sir, I have a general query. Sir, sir, if sir, when I solve the questions like where exact expression is given of an, then it solves easily. Like I apply MCT or solve it by manual calculation. But sir, when these inequalities are given, I always face problems. Like in this expression, an plus 1 is greater than equal to. Sir, please, can you tell us a general approach to solve these type of questions where inequality is given rather than equality or expression of general expression of an?
So if inequality would be given, so in such cases we have to more investigation now, just as I am doing here. So see, I tried 2-3 ways, and so yeah, that's the one thing that you have to investigate. Actually, without, see, I first tried this one with the term wise, but I thought maybe I don't want to go with this complication. But without, if you don't want this with this one, whatever we prove with the contradiction, if you don't want, then you have to analyze the term in the between the terms each time. If you see that this thing is happening, so for such problem, if it is inequality sign is given, then inequality tells you that what, your hand is open, you have to take here some any number could be there, but I'm just, so if it is inequality sign is given, no, so for such cases, so let me give you a trick also, that if inequality sign is given, then in those cases either assume the minimum or maximum value. Suppose you have, as I am taking this one, suppose a problem contain inequality, okay, some equations contain inequality. In those cases, try to take the minimum one. Okay, try to take the minimum one and go with the taking with the minimum. Okay, what is happening term by term, just take that what is happening. Even see, you can prove this one with the assuming, see, this is greater or equal to sign, no, you can remove this sign and assume that okay, our a1 is this one, a2 is this one, this is right. Even if you prove this one for this one also, that our sequence is not convergent, that there is no issue, because that is a true, because greater or equal to sign is there. For equal to sign, the sequence is not convergent. The how could be for the greater or equal to could be, because greater than says that more than numbers are, the terms are actually greater than that number. So even if you assume the minimum, or even if you remove the greater, this sign, just equal to sign, if you take, in those cases also, if you try to solve, you can analyze. So this is a process to analyze also. All of you are getting I am saying what I am saying?
Yes, sir.
Either took the minimum one, okay, as I am taking here, whenever you have inequality, take the minimum number, okay, for that, and proceed with the minimum number and see that what is happening, or just forget about this sign and think about this with this sign, because this sign tells you right, this is also happening, equality sign is also in that. So for such case, if you prove after assuming to be equal to sign, if you reaches some contradiction, the same process you can think for greater or strictly greater than the case, and then you can conclude that. You can prove this with the equal to sign also, and for the equal to sign also, the same way you can reach. Even if you analyze that okay, this term is actually 1 by 1, sorry, if you assume that okay, our a1 is equal to 2, a2 is going to be 2 plus 1, 2 upon 3, and a3 is going to be 2 plus 2 by 3 plus 2 upon 4. See that this is a kind of partial sum series you are getting. Each term is what? Each term is actually sum, right? Then even if you analyze that, the term, again the same series you are reaching, and this series is not going to be convergent. By this way also you can say.
But sir, in this question, we are we are assuming that, or we know in reality that this sequence is not convergent, this is a divergent. But sir, the question can be different. So sir, how can we approach that case?
So it's depend on the question of how you are analyzing. See, anyhow I try to reach that, okay, something we have to do that. So it's depend on question, like some minimum number, some bounds or something would be there. Even the once after assuming, I thought maybe that after taking that bounded above, after bounded above, can I apply MCT? Once I applied MCT, that is not working. I thought maybe I will reach a contradiction, but still I am unable to reach a contradiction. So I have to think with the different method. If it is not, then different method. If it is not, then different method you have to proceed.
So like in this case, you are trying to prove this series as divergent, and you have used several methods. Sir, is there any specific method to prove a series convergent?
There are many ways actually. So there is, sir is not taught in the lecture, but whatever I just now said, no, you can assume this one, whatever this one I said. If you have a series, okay, if you have a series by this way, where, so this series is convergent, okay, you can even take the result also. This is convergent when r is greater than 1, and divergent if r is less than or equal to. Okay, you can take this result for the time being. It may help for proving some other thing also.
Okay, sir.
This is true for in the series case. Once you start studying, once you come in the mathematics, so there is no use. No, this problem is given. I think to analyzing that, you have to think that, okay, if you suppose you are reaching that you don't know, then you can search on Google. That's why this problem is given in the assignment. That you should to know that, okay, what about this series? This series is convergent or divergent? Think about that.
I have one question, sir.
Mm-hmm.
If in the question, instead of 2 by n plus 1, it was 2 by n square plus 1, or a 2 by n plus 1 whole square, then would it still be divergent or would it become convergent?
So then it is a more confusing thing. So in that case, again, the series is going to be convergent. So this series is going to be convergent. But the inequality, so see that the inequality is there, no? The terms is actually greater than, so then it is going to be more complicated. So in that case, I'm not sure what is going to be happen.
So can't we just think of it like this, that even if the first term is 2, if there is a greater than equal to sign, then we do not know what the second term can be. It can be the next closest thing, which is, I believe, 3 by...
Yeah, that's the thing here. Unable to exactly get that number. So even see what is happening if you assume the equal to sign. If you assume that, okay, the sequence are equal to, having the equal to sign, for the equal to sign, you have the convergent thing. Convergent series you are getting. But for greater, but you don't have equal to. So in that case, you have to think about this greater than sign. And then you have open hand, then you are unable to exactly decide what is going to be happen.
Yes, it can be the minimum value. It can go to infinity also.
It is
so in that case, wouldn't it always, like almost always, be divergent?
I'm not sure. So I'm not sure about it. I have to also analyze for this. I have to analyze.
At least we can conclude that there is no upper bound if there's a greater than sign, because it can always go higher. There's no like number below which it can stay.
If it is greater than 1, 2 upon n plus 1 square, so by the contradiction, it's again the same previous one contradiction, no? That whatever we are getting this one. This one, we are saying that, okay, the bounded, it is not bounded above.
So about this, would you try this proof on another series, sir? That one is convergent, but I just want to see, sir.
Can we take later? Let me take that out first. Okay, so
yes, sir. Yes, sir.
Let me take that out, then we can think more after this. Let me take that out next out.
Yes, sir.
Because 1 hour I spent it here, but I don't know. Is that enjoying all of you or not? I don't know. Okay. Swin is done. Tanishka. Yeah, Tanishka.
Yeah, good evening, sir.
Yeah, hello, Tanishka.
Sir, I have doubt in 2 questions. One in practice assignment 4, question number 2, and 1 in activity question 6, question number 3.
So activity, let me take the first activity. Which activity?
So week 4, activity 6.
Activity 6. Which problem?
So question number 3.
Question number 3.
Yes,
This
sir.
one. So given function is continuous, then find the value of m plus n. So what is your doubt here?
Sir, actually I don't understand how to find the value of m and n.
Can you use this concept? Left limit, right limit, and function is continuous, no? So left limit.
Sir, I tried, but I am not able to reach the answer.
Right hand limit and function value. All are equal, right? All are equal in the case of continuity.
Yes, sir.
All are equal in the case of continuity. So what is going to be the left limit here? Yes.
So I don't believe that we need to even go to the limit. We can just equate the 3 and we can get the answer.
Equate to 3. Why will equate to 3?
Because at of course, like this is taking limit. Just equate all 3 of those to while taking x is equal to 3. So 3m is equal to n is equal to minus 6 plus 9.
So maybe, sir, the second option is right in this.
No, without that you cannot. You can x is equal to 3, then you will only get n, right? You cannot substitute here, not here also. What? Because at x is equal to 3 you have n. You can not apply on the other, because where the function is defined at here at x is equal to at 3, the function is exactly function value is n. Below of it is going to be this one, and greater than 3 it is going to be this one. So same way.
As it is continuous, can we apply that?
No, so this is continuous. So that's the thing here. When we will continuity, the left limit, right limit, and function value would be the same. So here is he said that without limit we can proceed. So without limit we cannot, because continuity says if you proceed with the limit,
Yes,
then continuity.
My bad. That just I directly put, because if we take the limit of a continuous function, then at 3 all 3 of the values should be equal. So I just directly put that without thinking.
So you have, so that's the thing here. If you are assuming 3 here, no, so let me write the function fx is equal to, we have some mx for x less than 3 and for x greater x is equal to 3, and this is minus 2x plus 9, 6 greater than 3. So this is we have. So what about this one? If it is left limit, so what is the meaning by left limit? At 3, function is continuous at 3, right? So even not 3, you just said that function is continuous. That means it is continuous at 3 also. So at 3, function is continuous. So what is the left limit means?
Sir, left means if we come from minus infinity to 3, sir.
So if you are coming to here is 3, suppose, so you are coming from the left side to 3. So left side to 3 means your function inputs are going to be lesser than 3. So in that case, how the function is behaving? By this, the function is behaving like this. So in that case, as now, can you tell me that limit as, so that means here left limit, this is the meaning of x approaching to 3 from negative side, from the lesser the side, less than 3 side. So then in that case, the function behaving like this, and in that case, if you substitute, you will get 3m. Similarly, if you are for the right side, for the right side is function behaving like this. So if you again approach to 3 from right side, right? So that means the function we have like this. Approaching means what? Your value, that whatever you are giving the input, it is not exactly 3, but it is greater than 3. From this side you are approaching. From this side you are giving the function value for the right side. For the left side you are giving the input to the function from this side. And for this side you have if you have graphed this one, suppose this side is mx, and this side is, suppose this is the negative side. This is minus 2x plus 9. This side is negative side. That's the meaning here. That's the meaning here. So left hand or greater than means your input is from this side, and for the right side, input is from this side. So that's why again the greater than case means right hand limit is going to be what? Minus 2 into 3 plus 9, which is what is that? This is 3.
Sir, means in all the cases we will put the same number like 3.
Because we are talking about around 3, right? Only 3. We are talking about 3. Because the continuity, where is the discontinuity or where is the problem with the function? Where is the problem? Everywhere. If it is less than x, function is what? Exactly smooth, linear. Right side of 3, exactly linear. There is no issue. But at 3, there is a problem. Around 3, we have a problem. So around 3, we will only think. Apart from 3, everywhere is smooth. This side is linear. So there is linear, linear is just continuity, means you cannot lift your pen. So left side means a straight line is there. This is a straight line, right? Right side is also a straight line. So right side is also smooth. Smooth in the sense continuous. Right side is also continuous. Left side is also continuous. The problem is at 3 and around 3. When you are around 3, left side is happening like this, right side is happening like this or like this. If it is negative, here is negative. So at 3, there is a problem. So how we can manage? So it says that we have information that function itself continuous. That means left limit should equal to right function value, left limit equal to right limit, and that is should equal to function value. So that's we are doing. So now we are at the point here. So left limit we got 3m, which the function value is what at 3?
3.
Function value at 3 is what?
Is equal to 9.
N we have, right? N. So this is equal to n, because this is left limit equal to function value. That means 3m minus n is equal to 0. And right, this is also, so n is equal to what? This is function value at 3 equal to right limit, which is 3 we have calculated. So finally, what it means that n is equal to 3 we have. So that means here, if you substitute here n is equal to 3, we have 3m minus 3 is equal to 0. So finally, m equal to 1 will get. So m plus n is going to be 3 plus 1, which is 4. Is that clear also? Left limit is what is
Sir, can you please explain it again?
Huh?
Can you please explain it again?
Okay. So, like this limit part is clear?
Yeah, from the 3m minus 3 part. So basically n was 3 from there.
No. This is what? 3m is equal to n, right? This is correct. Is this correct or not?
Yeah.
Because left limit is equal to function value. Left limit equal to function value. So left limit we got 3m. Function value is at 3n. So both should be equal. Correct?
Yeah.
That's what we are doing, nothing more. Left limit equal to function value. That we got this equation. The same thing is happening. Right limit equal to function value. So what is the right limit we have? What is the right limit we have? We just now calculated here.
The 3.
3.
Equal to function value. So function value at 3 is n, and right limit is 3 we calculated. So finally n is equal to 3 we got. This is what we have. This is for right, from the right it came. This is from left limit it came.
Okay, sir.
N is equal to 3 we got. If you substitute here, which is we substituted this one. So finally m equal to 1 we got. Okay. Another doubt? In which activity?
Sir, in practice assignment 4.
Which question number?
Sir, question number 2.
The same thing, no? The same,
Yes, sir.
exactly the same now.
Yes, sir.
Can we proceed now with the same thing?
Yes, sir. Now I will do.
Okay.
Thank you, sir.
Mani Shankar is the next one. Hello, Mani Shankar.
Good evening, sir.
Good evening.
Practice assignment.
Okay. Which question number?
Question number 3, sir.
This one.
Yes, sir.
What is your doubt here?
Actually, sir, I don't understand this type of series much.
So here is asking the Sn is the sum of the nth term. That means partial sum is asking, right? That is the nth term. Till nth term, the sum is there. What it mean that how we can write? So here, let me write with the way. So we have, okay, 1, even we can write 1 square. So 1 square plus 2 into 2 square. Then, okay, 3 square plus 3 square plus 2.4 square plus 5. Okay. Then, okay. So can you do one thing? Okay, can you do one thing that okay, I'm just leaving okay, when n is even, we have Sn is equal to this one. Choose the correct option for odd. So if you go with the option wise, see, this is problem with the different method also we can do, but I'm just suggesting you how for such problem how we can proceed. See, this is n is there, no? N is what? N is a natural number here, right? N is a natural number. So n is equal to 1, 2, 3, 4, 5, 6, 7. Any number we can substitute in the series here, in the first series I'm saying, correct?
Yes, sir.
So this Sn is here what? This Sn is for the odd is asking. So if n is equal to 3, we substitute. So what you will get? In the first, you will get S3 is equal to some quantity you will get, right? Something you will get here.
Yes, sir.
Is this quantity is equal to exactly for n is equal to till, right? This is 1, this is 2, this is 3. If you sum them, what is the sum you are getting here? 1
18
plus something and then plus something. 18 something you are getting. 9 plus this is going to be 17. 18 you are getting. If you substitute here the same number, because this sum is saying, right, this is the same Sn is there. Same thing. There is no difference. The partial sum, the meaning of the partial sum is the same. Correct? No? Yes?
Yes, sir.
So if you get here, if you, this is the comparing, no? You are comparing with the option and the whatever you have given the series. Just substitute it here and you think about the same. Even not 3, even 1 is okay. 1 is odd also, right? 1 is odd. For n equal to 1 itself, you can substitute and you can neglect some option. By this way, you can think. And the different method is that this is the first term, this is the second term, this is the third term, this is the what? Fourth term, this is the fifth term, and the something. So what is happening? The odd terms is what? Odd terms is what we have? 1 square plus 3 square plus 5 square plus 7 square, right? This is the meaning of odd sum. Odd term sum. Correct?
Yes, sir.
Correct? So what about this sum? I think sir have given. If you want to take this sum, what is that sum exactly? Anyone? I think sir have given this sum also in the video lecture.
I think this is the odd series.
Odd term series, odd term squaring series. So you are taking the square of the odd term. So what is that?
n plus 1 का whole square by 4.
N plus 1 by 2 whole square. This is
Yes, sir.
No, sir. This is the sum of natural number cube series.
This is, I think, n plus 1 into 2n plus 1 divided by 6.
Something is there in the video lecture itself, sir, told. And also without that, see, this is by option wise we can go. Even the different method, no? Sir, no, there is so many ways also. Like if you assume that, okay, just give that.
So another way, if we do not know the value of this summation, is to, since there is 2 multiplied 2 times 2 square.
Yes,
plus
yes,
2
that's
times
the
4
another
square.
way. That's the another way. That's what I was telling. So if it is complicated, it's look like complicated, no? That the better thing is go with the option wise. Just substitute n equal to 1 or n equal to 3. If you n equal to 3, that means till this you will get sum. So what is it says? Okay, what is the choose the correct when n is odd. So when n is odd, in that case, what is happening? Oh, sorry, I just missed that. This is not odd sum it's taking. Sorry, odd term sum is no. When n is odd. Oh, sorry. This is when n is even. So when n is even, we are getting, so n is equal to, suppose even, then in that case you will take this, suppose n is equal to 4, you are taking, the sum is going to be this and this, the whole, till here to here you will take. When n is equal to 5, which is odd, so till here to till 5 you will take the sum. So best thing is just go with the option wise. That's all.
So
that's the only way.
If I may interrupt, as I was saying, we could take, since there is basically 2 times 2 square, 2 times 4 square, so we can take 1 square plus 2 square plus 3 square plus 4 square and separate the 2 square plus 4 square into another series, and from that we can derive the equation.
Yeah, that's the also a way to find the sum. That's the way. How you can do, like you can take this term, and some other even term, you can take 2 common. This is going to 2 square, 4 square, 6 square, and by this way the same term, and the odd term is going to be 1 square plus 3 square plus.
No, because we know the summation of 1 square plus 2 square plus 3 square, we can create that, because 2 times 2 square is basically 2 square plus 2 square. So we can create 1 square plus 2 square plus 3
so
square.
here you mean to say even this is going to be 2 power 3, and this is what? This is the mean. This is going to be 2 square, something like that you are saying?
No, sir. We can write the second term as 2 square plus 2 square.
2 square plus 2 square. Okay.
Yes, sir. So one of those we can keep with the odd terms, and another we can keep on the right hand side.
Okay.
So extreme right. So that way we can create one series which is n square series, and one which is 2 square. If we take common, then that is also one n square series, but we'll have half the number of terms.
Yes.
And the final term.
No, another term is going to be 2 square plus 4 square, right? 4 square plus 6 square. This you will get.
Yes, sir. We can take 2 square common in this.
So if you take 2 square common, okay, this is going to be 2, right? This is going to be so this is not
2 square common.
Okay, 2 square we are going to take common. This is going to be 1 plus 2 square. No. This is going to be what?
Yes, 1 square plus
4.
2
this
square.
Is 2 square plus
3 square, sir.
3 square. Okay, this is okay. This is going to be correct. 3 square. Okay, again. Okay, this is going to be 1. And okay.
Yes, and there are going to be half as many terms. So we can just take if we are taking 2n plus 1 number of terms, which is odd number of terms, then we can take 2n plus 1 by 2 terms.
Yeah, this is one way also we can proceed with this.
Could you please explain, sir, 1 second, sir, what Subhasis has told, sir, please?
So he is saying that, okay, you have 1 square plus 2 into 2 square plus 3 square plus 2 into 4 square, okay, plus 5 square plus 2 into 6 square. By this way, so what he is saying that we can write 1 square. So we can write this term as a 2 this way, right? and this term is again 4 square plus 4 square. This term is 6 square plus 6 square, right? This alone term, right? And send this one term is with this way, like 1 plus 2 square plus 3 square plus, take 1 from here for this way, 4 square plus 5 square plus 1 6 for the this one. Okay, this is 6 square by this way. And the second one is, what is the second one? 2 square will get, 4 square will get, 6 square will get by this way. So this is going to be sum of n square. And this is going to be sum of, if you take here 2 common, 2 square common, so this is going to be again 1 square plus 2 square plus 3 square plus, this term is actually the same, this one. So again, this is going to be 2 sum of n square. So finally, what we got? We got what?
3 times sum of n square.
No, not 3. This is going to be what? 4, 5 times 5 sum of n square.
Not exactly, sir. Not exactly, because in the second one there are going to be less number of terms.
So maybe yes. So we have to think about that. So fine. So this is for n. We have assumed that. Okay. For m.
Very nice, sir.
Yes. But rectifying that is going to be difficult then in that case. Yes.
Sir, but how can we define the required formula in this case? From this case?
In that case we are not. So that's the thing here.
So we know the formula to n square. So we know the formula. It is n times n plus 1 times 2n plus 1 divided by 6.
It is asking for the even we have, for the odd how we can get. So for the even we have this
manipulate,
one.
no sir. We can manipulate. We can take 2n plus 1 terms. So that will always be odd.
Yes. Correct.
And that way we can manipulate for the even series also, for the 2n into n square series.
Yes. See, here is more consciously, if we write more consciously here, we can find the, if we write here more consciously, we can get a final, sum what is going to be. So that's why for the even case we needed, and for the odd case we needed. So here is for the even case, it is given this one. For the odd case, how we can find that. So for the easier one is just substitute n is equal to 1, 2, 3 for the right 1 or 3 or 5, and you can compare which option is going to be correct. Only one option is, because this is MCQ, and if you are not getting, you can go with the option wise. That's the easy way.
Can we also do substitution where n equals to, assume that n is equal to 2k for even, and for odd it is 2.
That's why I said we can spend time and we can do, but let's move on to the next doubt. Okay, if you have time, then we can do. There is no only one way to solve a problem. There are different method also. That's fine. Let me take the next doubt. Otherwise, we are not going to finish the doubt thing. Okay, Anand. Yeah, hello, Anand.
Yes, sir. Good evening, sir.
Good evening.
Sir, I have a doubt in graded assignment 3, question 10.
Okay, graded assignment. Which question number?
10. Question 10.
Is that question 10?
So, sir, in this one, I'm getting multiple answers. Like, if we go by 2 minus, and then after that it gets cancelled out. So the answer is 2. But if we take the nth term of this series, like if we take the nth term, like n 2 by n 2 by n minus 2 by n plus 1. If you do it like that and then take its sum, then I got confused. Like how, like if we do it in this way, how can we proceed to get the answer? Like I'm getting Tukat's limit.
So
And
anyone is here? How we can proceed it?
Sir, the
Sir, can I
terms
say,
have
sir?
been cancelled.
All the terms except to be cancelled, sir.
Actually, the terms is going. If you open that, the terms is going to be cancel.
Yeah, sir.
yes, I get it. But
Yes, sir.
if we take the nth term and then try to do it, then how to do
Yeah,
it?
still another term is. So that's the thing. Like what
Maybe
you
the
can do.
end term might get cancelled out with its previous term.
Okay.
So
No, I
see,
mean
process
doing
to
it with,
write that. See, if you somebody
In that
want to
case,
prove it, no.
the n term will tend to infinity, no, sir. Like 0, 0, sorry.
So
yes.
the process is what you can do, like partial sum meaning is there. No? So if you take the, suppose I'm taking, this is the partial sum. So what it means that this is 2 by 2, and then this is one term, then 2 by 2 minus 2 by 3, right? So okay, this is sum here, and then 2 by 3 minus 2 by 4. So what is going to be nth term now?
Sir, nth term of the series, if you calculate, would be 2 by n upon n times n plus 1.
This is going to be 2 by n minus 2 upon n plus 1. We have to
Yes,
see
sir.
the pattern here. So that it is here 1 and here is n plus 1. Sorry, 1 plus 1. Here is again 1 plus 1 and here is 2 plus that term 2 plus 1. So that's the happening here. Yes, yeah. This is the pattern. And if you substitute n equal to 2, 3, you can guess that this is the pattern you have. So this is Sn, the partial sum is this one. Now just open the bracket. If you open the bracket, what you will get here? This term is cancelled out by this one. This term is cancelled by this one. This one is cancelled by the next term. So what is that here? See the pattern here. So
Yes, I could see it.
the previous term is what? 2 upon the previous term is 2 upon n minus 1 minus 2 upon n you will get.
Yes, sir.
The previous one. So that means here that this will cancel out with the previous, and this is cancel out will be cancel out by this one. So finally Sn is what? Sn is 2 minus 2 upon
2 by n plus 1.
And now what is this? Partial sum is nothing but a sequence, right? This is a sequence is happening.
Yes,
You are
sir.
taking the partial sum. If you take the limit here, that means you are taking the sum till infinity. That's the meaning here. If you take the limit here and goes to infinity, that means you are taking the sum. So same thing here will apply. And if you take the limit as n goes to infinity, this will go to 0.
0.
And finally you will get only this one. Okay.
Yes, sir. Okay.
Let me take the next out. Mani Shankar. I think Mani Shankar is done. Satyam. Yeah, hello Satyam.
Yes, sir. Sir, graded assignment question 3 and 4. Week 3.
Graded week 3.
Yes, sir.
3 and 4. What is your doubt here?
Sir, here the concept of error in estimation I am not understanding.
Okay, consider a company that utilizes the 3 algorithm to forecast the future growth. Something is there, that algorithm, what is going to be like, you can think even the spreading of even the population, you can say. So this is an algorithm to gauge the population, something is there, or here is the future growth is given. So we are able to, that company have an algorithm to gauge that growth. The 3 algorithm it have. One is AN, the first algorithm is algorithm 1, the second is this one, third one is this one. The accuracy of this prediction, so this is the kind of algorithm his company is actually have the algorithm. This is machine learning, you can think. You have some algorithm and you are going to predict something. So that may have machine learning is, this is a qualifier. So machine learning is the based on this one. Okay. But this is an algorithm, and what is the thing is that some company have some pattern, and based on that he used to say that, okay, but after 15 years, this is going to be the growth. After 20 years, this is going to be the growth. Like with the algorithm 1, this is going to be growth. With the algorithm 2, this is going to be growth. So this is an algorithm to estimate the future growth. Okay, prediction is influenced by the amount of available data represented by the positive integer n. So the accuracy of this prediction is influenced by the amount of available data represented by the positive integer n. The relationship between the error in the estimation and data quantity is as follows. So even this one, no, whatever this one is given, this algorithm is have, what is that? This is an error itself, it says, right? No, it is not clear. Is it clear that this is an error itself? This is an error, like the future growth. Some have algorithm which have error. The algorithm 1 have some error, this one. Algorithm 2 has error, this one. Algorithm 3 have error, this one. This is the meaning. No?
Yes, sir.
This is this word is giving the information, the relation between the error estimation and the data quantity. So n is the data and error and the relation between the error estimation. So this is a error, defining the error. So let's do that. How the option, which algorithm give the minimum error while predicting the company's future growth. So future growth means even you can think, right, the future growth you can think with the n goes to infinity. Here is the assume that, okay, even itself that assume the company has, so n is actually data. Here is no, not n is a time, n is a data. No, and here the amount of the available data represented by the integer n. So n is a data. Based on the data, that error is estimated by this one. Based on data is error. These are the error of given by the company with the whatever in the algorithm 1 have, algorithm 2 have, algorithm 3 have. So if data is larger and larger, suppose the company have get the data larger and larger. So surely if it is, you have, like, suppose you have that I think there is no. So if you have, suppose, these many data, and based on this data you want to predict something, okay, that what is going to be, suppose you are making a home and you have a less tools. Okay, you are making an home, you have only suppose you have only that bricks. Bricks is a data, right? For the one creating one wall, bricks are data. And the second, you are creating a wall, you have not only bricks, you have some cement also. So it will more accurate, right? So as the data will increase, the accuracy depends on that, how is that accuracy is increasing and decreasing. Here is the information, that error, this is the error part is given. So what is going to be there, as n is going to be larger, n is going to be larger, very large, so which have the less error, minimum error. The algorithm 3 says which have the minimum error. So that means here just find the limit, no? Each time just find the limit, and that is going to be, what is going to be limit for this sequence?
1/3.
Sir, first one 1/2, and the second one 1/3, third one 1/4.
First one is 1/3.
Second one is what?
1/2.
1/2.
1/2.
And third one is what?
1/4.
1/4.
So now you can compare. 1/4 is lesser.
Algorithm 2.
So that's the thing here. 1/4 is lesser than 1/2 and 1/3. So that's why it is going to be the minimum. I don't know who had asked this problem. Are you getting?
Yes, sir. I'm getting.
Satyam, that no, this is the error part.
Yeah.
Error. This is the estimated error. This word itself, the relation between error estimation and data is given. So data is there and error. This is the error part. And which is as data is going to be larger and larger, what is going to which one is give the minimum error? Similarly for this one, which algorithm gives the maximum error? So which number is going to be greater than max? So 1/2 is greater than 1/3 and 1/4. So then that's why the second algorithm is going to be give the algorithm maximum algorithm error.
Okay, sir. Thank you.
Faisal is the next one. Hello, Faisal.
Yes, I have a doubt on the same graded assignments 3, but the first question.
First problem.
I got the bounded below and sequence is increasing, I understand. but it also says it's bounded above. So
it says bounded above. So
yes,
how we can prove it?
I did not know exactly how it is bounded above.
Okay, let's do it here. So see, okay. So AN we have. So is this increasing or decreasing?
It's increasing.
Increasing.
So we have okay. So we have AN is okay. So if you do a square, no. So if you do a square both sides, so this is going to be AN square, and this is 12 plus 4 AN minus 1. So how we are concluding this? Is this increasing?
If you take the results, if you substitute n equals 0 and then n equals 1, 2, 3, you'll see the values increase.
Putting 1, 2, 3.
And by this way, you are guessing that it is increasing thing.
Yes, sir.
So you can see that generally once you conclude, even suppose that's the one way that this is the MCQ problems. That's one way you can assume, but the best way is that you have to reach that AN plus 1 is greater than AN or not. Is this happening or not? Is greater or equal to not. The same. That's why if AN is this one, just square that, you will get this one. Now you have this one. So if you do what? AN plus 1 square minus AN, left side, if you just subtract here, you will get what? 4 AN minus 1, right? This you will get. Correct?
Yes, sir.
Okay.
So this is going to be AN plus 1 minus AN and AN plus 1 minus AN, and this side, if you send that, this is going to be, this is plus here somewhere. Okay, still is this giving the information to increasing? So this is going to be 4 AN minus 1. Okay, so this we have AN plus 1 minus AN. If I take common here, so this we will get here AN plus 1 plus AN minus 4. This is equal to 0. I send this side. So A1 is equal to what we have? 1, right? A1 is equal to 1. Sorry, A0 is 1 is given. A0 is 1 is given. So A2 is what? So here is A1 is 0, then
4.
So is this number is going to be 0? Is this number is going to be equal to 0, or is this number is going to be 0? Because we have 0, no? Here we reaches something that AN plus 1 minus AN is going to be equal to 0. Is this number ever will be 0?
No, sir.
Why?
Sir, I could not understand the second to last step. Like, where did AN minus 1 go, sir?
I just sent this side, no? I just sent this side and I took common AN minus. Oh, here is sorry. Oh. This is AN plus 1. Oh, sorry. Oh. Okay. I missed that part. So this is we have, so we are not going to use this one also. So
sir, can
this
we
is
try one thing? Just assume that the upper bound exists. Just assume that, and
no, I just asked that how you are proving that is this increasing. So only the way you said that, just substitution, no? That 1 by like A0 if you substitute.
Yes, so that I'm saying, if we assume and we get a limit, then does that not prove it that limit exists, or it is bounded above?
Limit limit exists, but it's not equal to it. So if it is bounded, it has to be less than or equal to that particular value. That is the limit.
So suppose that I'm just, for the time being, I'm saying that suppose it is a bounded above. So suppose I'm saying this is bounded above. Suppose this is bounded above. Suppose this is bounded above, and you said this is increasing. So what is going to be in that case? MCT you can apply. And
MCT
then,
applies.
And then this is going to be L square is equal to 12 plus, if you take the limit both sides, what is going to be? L square is equal to, if you take the limit is L. Now if we are able to apply, then suppose sequence converging to L. So this is L square is equal to 12 plus 4an minus 1. Sorry, this is going to be 4L. Right?
Yes, this is a quadratic equation, and we can get the answer from this.
So you will get the answer.
That's 6.
You will get the answer. So what is the answer coming?
6.
Minus 2 and 6.
Minus 2 and 6. So as the function is
so minus 2 get rejected.
So minus 2 and 6. So 6 is going to be the limit. So what we can do, no? So here we will start thinking. So for the time being, just assume that and you got the limit. So what you can think that, okay, so this is an is what, see that a1 is, a0 is, now from here you can start thinking that a0 is less than 6, right? A0 is 1. What about a2? A2 is, you have, what is the a2?
A2 will be root 28.
Root 28. Root 20 is less than 6, correct?
Yes.
Root 28, sir.
Okay.
Yes, sir.
So,
5.75.
Induction, no, sir is said in the induction. Assume that. So see, for the initial stage, that the base case is cut. The base case, assume for A0 is true. Now assume that, I am just proving it, assume that this is true for AN also, less than 6. So even greater or equal to, keep that. This is true for AN also. Now what you can do what? You can add 12 both sides. Okay. This is, or even you can multiply both sides. 4. This is less than 24, right?
Yes, sir.
Now if you add both sides, 12. What is going to be this
36.
one? 36. Now if you take the square root both sides, 6 you get, right?
Yeah.
Positive square root. 6 you will get, correct?
Yes. Sir.
And what is this term? This is AN4.
AN.
So by induction, can we say that this is true for all n?
Yes, sir.
Yes.
Yes, sir.
Now we can say that is this in bounded above?
Yes.
Yes, it is bounded.
Yes.
This is now bounded above. So this is the one way to prove actually. So if you are not getting the exact how to prove that, or one way how is that how we can reach the bounded above or not. So by this way you can, by this way, if it is bounded, so assume that that is bounded, then MCT can apply, then you can find the limit. So that's why the increasing is more important. Once you know that it in increasing and bounded above, you can assume, okay, limit is exist, you can assume L. So now as 6 is going to be limit, and what is the MCT? MCT is what MCT says? Increasing. What is the mean by increasing? Means anyhow, what is the bound is there, no? That is going to be your limit. Function is increasing, and what is the bound is there? The minimum, that bound is going to be your limit. So 6 is, that's why the limit. If you check with the each term here, as here we proved now, this is going to be true for all n.
Okay, sir. Thank you, sir.
By this way you can prove. Sometimes you have to go above and then back to, like here. What we are doing, we are assume that bounded, we keep one step ahead, and then from there we get something. Oh, 6 is some number. 6 is going to be some number, so that number is going to be lesser than. Then we can prove actually. Or even no, from here also the different method is that exactly getting that 6 we got using the limit, no? We got 6 using the limit, but here is after writing some term like A0 you got 1. What is A1 is going to be root 20. What is A3? Sorry, A2? A2 is going to
A1 is going to be 4, sir. A2 is going to be root 28.
Root 20. So roughly, so what is this amount? What is this amount?
5.29, sir.
5.29.
5.2. And the final is, if you add this is what, how it will go?
Final value is 5.29, sir.
5.29. So roughly it will go 17 or 18 and root of it. So no. Roughly it will go more than the 20 because it is an increasing. Okay. So I think this is the only way. I think this is the, after assuming this is bounded.
You can suggest the values were not correct, sir. A1 will be 4 and A2 will be root 28.
Yes, sir.
So what is going to be this value? I don't know what is this value is going to be.
That will become 4 root 28 and it will become 5.75.
This number will 5.2 something.
That is there's something wrong because to get root 20 we have to root 20 is greater than 4, sir.
Root 20 is greater than 4. Yes.
I mean A1 is going to be 4, sir, because A0 is 1, A1 is under root
4 into 4, 16 you are saying. Something 16 so you'll get.
Yes, sir, root 16, so 4.
Okay. Root of 20 is what? Root of 20 is 4 square is what? 16, right? So 16 you will get, no? Here is something you will get roughly 16, no? This is 6.
A1 will be 16, sir. Root 16.
A1 is going to be root something roughly 4 is there.
47. Root 20.
Sir, A1 will be root 16, sir. If we take A0 value, then A1 will be root 16.
Root 16.
That is the value of A1.
Okay. That's why why then some people saying this is going to be 5.2. This is, we are roughly getting 16, no?
That's the.
I'm not saying this one. I'm not saying this one. I am just asking what is this value? This value only. This value, inside value.
So that value is not the A2, sir. That is not A2.
That is not A2. I'm just asking. See, I am trying to get this bound. No, this is actually to reach the bound. This is one way to guessing the bound. Whatever I know.
Sir, it is 4.28. So
it's the bound.
5.79.
This is one way to guess the bound. This is roughly what? 16. What is this? 12, 16, 28.
No.
17.7.
28.
Roughly 16 or 17. That's the thing. Roughly 16 or 17. See, this is one way to guess exactly that what is where the all number is actually coming. That's the one way to get that. Otherwise, this is the only way. So the different method I don't know. If you assume, apply MCT, guess that upper bound and try to show that is that upper bound or not. That's the only way. Otherwise, if you are able to guess, as I am guessing here, if you are able to guess, then you can guess.
Okay, sir. Actually, also,
approx 15, 16, sir.
Approx 17 or 16 will come. So that means you will get roughly 28 or 29. Then A3, actually A3 is roughly 29, root over 29. So then again you have to think for A4. Then slowly you will get that, okay, some number, some around root over 36, the all number will convert. Something, if you check that, like till A5 or A7, till A9, you will try to get that and you will see that roughly around root over 36, all numbers will come. Then you can assume that, okay, never the all number is going to be greater than 6, and then finally try to prove with the induction. This is one way to prove without even assuming this bounded above. This is one way to guess that and then reach to the final. I'm just telling all of you the approach, whatever I know. I don't know the.
Sir, in the previous classes, sir, during qualifier exam, you have suggested to find the values of A1, A2, A3. Here A1 equal to 4, final value equal to 4, sir. A2 equal to 5.29, A3 equal to 5.75, sir. So it is a gradually increasing sequence, sir, divergent sequence. But as if we calculate from A0 to A1, there is increase of 3 units, sir, 3. And from A1 to A2, sir, there is increase of 1.29, and from A2 to A3, there is increase of 0.46.
So slowly it will decrease, no? Slowly it will decrease. Slowly,
Yes,
slowly it will
that
reach
means we
to.
can conclude it is bounded, no, sir?
This is one way to say also. Like, what is the exact bound? That says roughly you are saying that it is going to be bound, but what is the exact bound? How we can prove is it bounded above?
Addition of all the age, that is something around 15, 16.
So I think so by this way you can go and then prove that how it could be bounded above. That's the one way. Otherwise, guessing can help. And once you guess that number, no, and then try to prove that. That's all. Okay. Let me
similarly,
sir,
similar question is there, sir, in question number 6, sir. In a similar way, I have calculated all the A1, A2, A3, sir. But one option is coming wrong, sir. Please limit full, sir.
Here about the 6th problem.
Yes, sir. Yes, sir. After calculating A1, A2, A3, similar method gone, but one option getting wrong, sir.
So see, what is that? If you see, here is first thing is inequality is there, and second thing is even your hand is not like here you this way, no, this I said, no, each time you are just take the minimum one, and what you are getting +2 each time. Minimum one is added with +2 +2 is there, and also there is one bigger series is happening, always going to be greater than 2, and some additional number is there. This number is actually will tell you that is going to be bounded above or not. That's the only I am, as I now I am looking there. There is no other way.
Sir, it is bounded below, na, sir?
No, this is not bounded below. This is bounded below. This is bounded
Question
below.
6.
This
but
is,
I have, but it is okay, sir. But I have also selected it is bounded above, sir.
No, so this is not bounded above. We just now we proved it.
Sir, how can we put this on Desmos?
Which one?
This series.
This series. This one. Oh, series
Yes.
you are saying?
Yes, sir.
Any series.
Oh, so any series if you want to know. So if you want to put in series, so in place of n, you can assume x, because see, x means what? X is any real number, no? Natural number is part of the real number. By this way also you can think. See, n is increasing means x will also increase, right? For real number I am saying. No? Yes, no?
Yes,
okay.
Sir.
Yes, sir.
N is increasing means our real number is also increasing. No? So in place of x, just substitute x, and you have the function x in function x, and you can put in the Desmos also. Here itself you can see that. Even let me show you with this first problem. So in place of c, sorry, here is not n is given. So suppose for n is given, suppose here is n is given, no? Suppose here n is given, so in place of n you can substitute x, and then just plot in Desmos, and whatever the behavior in the Desmos will happen, the same behavior will also happen here, because the natural number is subset of real number, right? Natural numbers are subset of real number. So whatever there will happen, the same natural number will follow. For the real number, if it is follow, the natural number will also follow.
Okay, sir.
Aditya is the next one. Hello, Aditya.
Sir, I have a request, sir. Sir, if time allows and if you are comfortable, then sir, please take a session in which we can go deep inside sequences and series, sequences and limits, and the question like inequality we can discuss.
You know, that's the thing, like See, the sequence and series is not a small thing. No? Sequence is a bit easy, but series is not a small. In the series have lots of concepts are there. Even you cannot finish in 2 hours. It's needed more things. So, and also see, the question is not going to be asked. This MCT is only one. So see, even if you see that whatever I told you series, that series itself in the lecture, and yeah, that if you practice with the MCT, no, MCT problem is, if you search on MCT problem and try to practice more, only the problem related to the MCT. If you see that many problems depend on the MCT, and the MCT is generally on the recursion. That recursion problem, that recursive, this kind of recursion is there. Recurrence. See, that is the kind of recurrence is there. Recursive problem. This is one kind of recursive problem. The 6th problem is kind of recursive problem.
Sir,
so if you practice on the recursive problem, applying on the MCT, if you practice, that's enough. I think that's enough to deal with that.
Okay, sir.
Mostly MCT will use that. There are so many problem. Even that book. Yes, I'm not remembering that. Like, there is different problem. Even let me create one. That is that is S1 is 7. Then what is going to be in that case? Sorry, A1 is going to be 7. Then what is going to be in the case of if it is a kind of AN plus 1 is equal to 7 minus AN, or many different. Just a minute. Is that even let me write a different example, that if S1 and S2 are positive, okay, or are positive, 2 terms, S1 and S2 are positive, even you can change with the A1 and A2, are S1 S2. S1 and S2 are positive, then what is going to be the sequence with Sn plus 2 equal to root over Sn plus 1 plus Sn. This will also use MCT. This will use MCT. This will use MCT. Another problem is there. That problem is, if what about this sequence? You can tell that again, this is a recursive problem. Fn is equal to that sequence an. An is equal to an minus 1 plus an minus 2 upon 2.
Sir, only recursive functions can can apply. We can apply MCT on recursive sequences only.
Many other problem also, because MCT is for the general. No, what about is what even you can use this this problem 1 minus 1 by n. You know that the sequence is going to be goes to 1, but you can apply here MCT. This is what is this sequence? Sequence is increasing or decreasing?
So it's decreasing sequence.
No, increasing. No, this is increasing sequence. Why?
Increasing because the 1 by n is going to 0.
So 1 by n is going to be 0. So this is increasing. No, what is this number? What is this sequence in the line? How it will show? Suppose here is 1. So what are the terms where it will lie? Left side or right side?
This is going from 0 to 1, sir.
So where the terms? Suppose you have this sequence. That sequence will lie left side to 1 or right side to 1?
Left side.
Left side, right? From here to it will go to 1.
Yes, sir.
Because 1 by n, if you increase the number, this is going to be 0. So that means what? This is happening increasing sequence. And what is the bound of this?
1,
what
sir.
Is bound? Upper bound. What is the upper bound?
1, sir.
1, because if here is the negative sign, always subtracting here. So now you can apply MCT and say that, oh, this sequence is convergent. The sequence is directly, you can say the convergent. So MCT is not only for recursive, it is for any kind of sequence can apply. But generally, if it is a recursive, no, so in that case, you don't know the terms. So in that case, MCT will much helpful in the case of recurrence relation or recursive problem. So even you can search on internet, okay, recursive problem, even directly search on the internet the recursive or recurrence problem solving with MCT, or you can just Google on and you can find some problem there, solve those all. That will enough to practice. Once you practice on this such kind of problem, no, you will able to deal how to get that, how to guess that it is increasing or decreasing, how we'll prove that it is a bounded above or bounded below. If you solve 4 to 5 problems, that's enough.
Sir, in this 1 minus 1 by n sequence, sir, first term is 0 as n equals to 1.
Yes.
First term will be 0. Sir, second term will be 1 minus 1 by 2, which is 1 by 2. Okay, so sir, this is increasing sequence. Yes, sir, I got it.
Sir, whether increasing or decreasing, sir, when there is a limit, then only we can say it is convergent. Otherwise, it is divergent, sir. Whether increasing or decreasing.
If it have a limit, then you can say convergent.
Otherwise, it may be divergent.
It will be divergent.
Whether
and if you are saying convergent, it means that that sequence have limit. Convergent and limit are the same thing. Okay, convergent says your sequence is convergent, means you don't know the limit, but yeah, you can say that, oh, this sequence have a limit. That's the meaning of convergent. And in other word, if the sequence you are saying this sequence have limit, that means you can say the sequence is convergent. Convergent word is for a general term, that if your sequence is convergent, then that means that sequence have limit.
Okay? Sir, could you please discuss in a small about week 3, sir? Week 4.
So now the time is running over. In the next session, that is on, will come on Tuesday. We can discuss that on that day also. And MCT is like we did many problem. Computing limit is, I hope all of you know that. Examples on convergent, divergent is meaning just now said bounded above, bounded below. I showed some example how to series is the here sense. Problem related to function. While discussing the doubt itself, we spent time much. So let me see. Anyone have doubt? Anyone have doubt? Doubt here?
No.
So the terms, whatever the, like who is here, the terms, you are all of you know that what is the bounded meaning?
Yes, sir.
Bounded above meaning, bounded below meaning.
Yes,
and,
sir.
Increasing when we will say increasing, and when we will say decreasing. And then the limit, what is the limit? So the limit in one word is that, what is the limit of a sequence means? Limit of a sequence. Limit of a sequence is what? See, sequence is nothing but sequence is a function from natural number to real number. For example, n cube plus 5n square, 7n cube plus 2. See, this is a function, right? This is a function in the n variable. N is a variable where n is taking the natural number input. So sequence is a function where inputs are natural. Domain is natural number. Even you can change the sequence with the, you can think that this is a nothing but a function. X cube plus 5x square, 7x cube plus 2. The same thing is there. Whatever the behavior of this function is having, this behavior, whatever the behavior this function contains, the same behavior will follow with the sequence, because natural numbers are subset of real number, because real numbers are right. negative numbers are there, positive numbers are there, but natural numbers are what? Counting numbers, 1, 2, 3, 4, 5 to infinity. The some counting numbers are there. So whatever the behavior this function have, the same behavior will occur with the sequence also. Okay.
Sir, in one question, sir, here it is given two options. One is from natural to real numbers. Another is from, sir, natural to, sir, I think integers, sir. Both are correct given, sir.
Both are sequences, because sequences only, what is the sequence? Sequence is nothing but a function which have domain natural number, that's all. Only this part is more concern. Your number is actually counting. The codomain is anything. Codomain is the output. What are the output? Here is output, no? It is a rational number. This is a rational number. Means if you give x value something, or even if n value something 2, you will get some fraction. That is a rational number. But here counting number. Natural numbers are counting number, no? 1, 2, 3, 4, 5, 6, 7. These are the counting numbers. Yeah. Even 0, if you want to include, you can include in 0. 0 also there. Sequence, don't worry with the sequence. Sequence is exactly a function, nothing more. Only the domain is restricted, and in that, even I will say you sequence are easier than function, because in function you are able to give irrational number, rational number, root 2, root 5, any number. But in sequence you only give input 1, 2, 3, 4, 5. That is the easier thing, no? You are able to count that. But function has any input. So sequence is easier than function. Sequence is actually why we are studying sequence. We are actually breaking. Suppose we want to study about the property of this function. So we are breaking our problem in the counting number. On the counting number we are trying to study. So sequence is that only, nothing more. So sequence is actually easier than function. We are actually studying some part of the real number. Sequence is easier one. And limit is, what is the limit? Limit is actually when we are giving a very large input in, as here, very large number, where the output is coming. Is that output is fixed number, around that fixed number is coming, or it is going to be infinitive? You are giving input very large number, output is also very large number or not? That's the limit. That's the here convergence means. If it is the fixed number, around that fixed number you are giving very large number inputs as input, is that number is coming some fixed number, or itself it is giving a very large? That's the difference. That's the meaning of limit only. Limits are sequence is easier than function. Okay. Is that clear? Something?
Yes,
Yes,
sir.
Okay.
Sir.
Okay, so we'll see in the next session. Try to do more practice. Let's see what will happen. Okay. Thank you so much for joining.
Thank you, sir.
Thank you,
Thank
sir.
you, sir.
Thank you, sir.
Dhanyavad, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.